I'm in SPSS and I'm going to look at doing a chi-squared test of independence, and this is something that we would do when we've got two categorical variables. This dataset has come from one of the Mythbusters episodes where they wanted to see if observing a person yawn would in fact induce a yawn. So are people more likely to yawn if they've watched a yawn? So the treatment in this case is that they watched a yawn, and the control is that they didn't watch a yawn. The participants didn't actually know that this was the experiment. They thought they were doing something else from memory. It's been a little while since I watched the episode. And then the outcome that they've measured is just noted down whether or not they have yawned. Now, hopefully you have in your data set one row for each person, each unit of analysis, and in which case you'll have something that looks a bit like this, going all the way down to 40 or 50. It's possible you have tabulated your data, in which case it is still possible to run the test. You just got to do a little bit of a fiddle. So I'll show you this way first, and then you can stop listening if you don't need to hear the second way. So we go to Analyze. Now you might think you would go to Tables, and you would be wrong. You would go to Descriptive Statistics and go to Crosstabs. I've already put these in. I'll take them out and put them in again. So I'm after my second lot here, groups with the S and yawns. So groups, doesn't really matter which way around you put it, just depends how you want to read it. I'll put the groups in the rows and the yawns in the columns. Now statistics. So we want the chi-square test. Now if you want your odds ratio, you might think there would be something here which says odds ratio, and you would again be wrong. It does not say odds ratio, it says risk, so you need to tick this box here. SPSS is nice and helpful that way. So continue, and then in the cells it's helpful to see the observed counts. I also like to see the expected counts, so this is what we would expect to happen if the null hypothesis was true. And if there is a difference, it helps to have the standardized residuals so that you can work out which combination is having the largest effect. So which group is doing what we didn't expect them to do, and we can tell that from the standardized residuals. Don't think we need anything else. Won't need bootstrapping. Nope. Okay, and you can get it to do some bar charts while you're there if you want. Okay, so there's loads of output here. The first bit just tells us if there's any missing data. Hopefully you won't have any. We've got 50 observations and they're all valid. Our groups, we've got control and treatment, yawns, the number of people that didn't yawn and the number of people that did yawn. We've got our count. This is the observed value. So there were actually 12 people in the control group who did not yawn. The expected count is if there was no relationship between getting the treatment or being in the control group and whether or not you yawned, then we would expect to see 11.5 people in this group. So that's pretty close, and that has a low standardized residual because it is so close, the expected with the observed. So a small standardized residual is probably between -1 and 1. A large standardized residual will be out towards 2 or 3, or -2 or -3. Now the chi-square test here, we're interested in the Pearson chi-square. The value is the value of the test statistic. The null hypothesis is that there is no association between the two variables. The asymptotic significance two-sided is the p-value, and that's 0.746, which is very high. So we have absolutely no evidence against the null hypothesis, and therefore we have no reason to believe that observing a person yawn, which was the treatment, has any effect on whether or not you yawn. However, one cell has an expected count less than 5, and so the test may not be valid. So we should interpret these results with caution because it is a small sample size. Now, where we would expect to see the odds ratio, we have what's called the risk estimate. Now the odds ratio is just this top line, and these bottom two are relative risk calculations which you can safely ignore. Now depending on which way around, I suggest you go through and calculate the odds ratio by hand just to make sure you get the interpretation the right way. So I believe this says that for every one person in the control group, 1.25 people in the treatment group will yawn. So every one person in the control group who yawns, there'll be 1.25 people in the treatment group who yawns. Now, if the odds is 1 for every one person in the control group that yawns, one person in the treatment group yawns, then that's no difference between the groups. And you can see that our 95% confidence interval here includes 1. It goes from 0.3 to 4. So there really is no difference here between the groups. And that is what we would expect given that we had such a high p-value and the chi-square test didn't find a difference between the groups either. So that is chi-square test if you have your data set up with 1 row per observation or unit of analysis. If for some reason you have already tabulated your data, you can still run this test. You will need to have it set out like this, where you have your group and your yawn. So you have all your combinations here. Treatment and yawn, 10 of those. Treatment didn't yawn, 24 of those. Control group yawn, 4. Control group didn't yawn, 12. Now what we're going to do is call this our table, but we're going to weight by the counts. So we need to go to Data, Weight, Weight cases by, and frequency is already there because I just checked that that worked before. Okay. If you do this, make sure you turn it off again before you do anything else if you've got other data sitting in there, otherwise you're going to get strange results. So analyze. Don't go to tables. Tables are not in tables. Tables are in descriptive statistics under crosstabs. Crosstabs. Now this time we want our first column, so that's group and yawn. Now we don't have to do anything with the frequencies, the counts here, because we already selected that when we went to data and weight cases. So it is already going to do that. This will be the same as before. We didn't need that. The risk estimate for the odds ratio, chi-square test, and the cells, observed, expected, standardized residuals. Okay. Now we should have exactly the same output here, and I can't see any differences. It may just put these the other way around, so actually I think that's the same. Control, treatment, no yawn, yawn. Control, treatment, no yawn, yawn. It's actually come out the same way in this case. It's possible that your columns would get mixed around the other way. P-value is the same, odds ratio the same, so there's no difference there. So that is how to do a chi-square test in SPSS.